Hi there, I'm Dave Horton, the creator of Jambones, the open source communication platform as a service, the CPaaS that you can run on your own infrastructure. And in this video, I'm going to show you soup to nuts how to build a Jambones cluster in 10 minutes or less. All you're going to need is the software itself, which we'll get from GitHub, some AWS credentials, because we're going to run it on AWS, and you may want to use AWS for TTS Poly for your text-to-speech, and some Google GCP credentials as well, because we're going to use Google for speech recognition. But anyways, let's get right into it. The place to start is on GitHub. There's a Jambones organization, and all the repositories are there. There's some links to docs page as well from there. And if you're not familiar with Jambones, you may want to visit there. It will give you an overview of the project and who it's intended for, and you can also do a deep dive into the language itself, the verbs, and so forth. If you've got experience with other CPaaS applications, hosted applications, this will all be pretty familiar to you. But there is a repo called Jambones infrastructure that we are going to clone and then run. It includes both Packer scripts to create a couple AMIs, as well as Terraform scripts to create everything that you need on AWS to run a Jambones cluster. So let's look under the Terraform directory. There are two directories under there, Jambones dev test and Jambones prod. Jambones dev test is designed to be a small development and test environment or a small production environment consisting of one session border controller and one feature server. So first thing we're going to do, let's check out this repo from GitHub. Now, once we do that, two prerequisites that we need are credentials from both Google Cloud and AWS. We use Google Cloud for speech recognition, and we use AWS, and we also use Google Cloud for text-to-speech. We use AWS for text-to-speech, if that's your choice. And of course, this is running on AWS, so we need AWS credentials for that as well. That's why we need both Google and AWS credentials. And I'm going to show you how to generate both of them in just a second here. You can see in the dev test folder here, we've got a Terraform project. Those files that end in TF are Terraform files. The one that's most important that you'll make changes to are variables.tf, because in there you will put some choices like which AWS region you want to deploy in, as well as your AWS keys. Let's go over to Google Cloud. What we need to do is create a service account under our Google project that we've designated we want to use. And then we need to generate a JSON service key for it. So let's go ahead and do that. I've already got a project set up that I want to use. So I'm just going to create a new service account. And call it something. Jambones testing video, for example, and create that. And then just generate a JSON key for that. You can see I don't have any keys for this service account I just generated. I create a key, it downloads it. I want to make sure I pick JSON, and it downloads it to my computer. Now, the important thing is that file we want to go under the credentials subfolder of the Terraform project that we're in. So in the Jambones dev test project, there's a subfolder called credentials. It's empty. We need to copy that GCP file, and we need to give it the name gcp.json. I'm going to give it a specific name by convention. And we're just going to change the permissions on the file as well. That takes care of GCP. Now, let's have a look at it, quick look at the project in the editor. Again, there's a few files there, including a README, which you'll find to be pretty useful. It kind of walks through the steps that we're going to do. But the most important file, and probably the only file you need to change will be variables.tf. It's got a selection of variables for things like which region you want to deploy in. I'm going to deploy in US West 2, so I'm going to leave that blank. You also need to specify the subnets. You need to create at least 2 subnets in the region. And so if you were changed to a different region, you'd be changing the name of those subnets as well. You get a choice of the instance type. Now here's some things that you are going to need to put in. One is your SSH key. So in the region you deploy, you want to have generated an SSH key on AWS, and you'll put the name of the key in there. And then down below, you'll put the key, the actual path to that key file on your computer. So I've got a key called AWS Jambones US West 2. I'm going to use that one. And that is in a folder on my hard drive called AWS. So I'll put that there. And now right below that is where I need to put my AWS key. Again, these credentials are going to be used both to set up the cluster as well as to use AWS TTS Poly. So I go on to AWS and I'm just going to create a key. Not worry about obscuring it because I'm going to delete this key after I'm through, but we'll copy that access key ID and the secret access key into the config file. Of course, you'd be putting your key in here. Now, all of these variables can be specified on the command line when we run Terraform as well. I happen to be doing it in the variables.tf file, but it's just as easy and probably better to do it on the command line. Make sure you never check in any AWS keys or anything like that. Now, having done that, the rest of the choices are pretty standard. I'm not going to need to edit any of them. There's some options which I'm not going to fill out right now. So this is the basic. Now I'm ready to run Terraform. I'm not going to go through how to install the Terraform CLI. It's pretty straightforward. You get it from HashiCorp. I'm going to run Terraform init to initialize the AWS plugin. And then I'm all set. I am ready to run Terraform apply. And what it's going to do is create a VPC in my selected region. It's going to create 2 EC2 instances. One is going to be an SPC, one is going to be a feature server. It's going to create an elastic IP. It's going to put the feature server into an autoscale group, and it will create an autoscale group. It'll create an elastic cache key value store. It'll create also a MySQL Aurora database. And it will create a bunch of other things that we need, such as security groups and so on, such that when it's finished, the entire VPC cluster and functionality is ready to go. Okay, and now it's going to start creating these things. I'm going to speed it up a little bit because it does take a bit of time to create the database and the elastic cache instance. There, we're done. Let's go in and let's have a quick look at what we've got. I'm in the US West 2 region where I didn't have anything running before. If I go to the EC2 dashboard, I can see I've got 2 instances running now that I just created. We'll bring that up and we can see one is a feature server and one is an SPC that has both SIP and RTP signaling. It is possible to split those, but in a dev test cluster, I keep them the same. We've got an elastic IP associated with the SPC. We've got an autoscale group that the feature server is running in. Take a quick look at that. I've got a placement group that's associated with that and so forth. We use simple notification service for lifecycle notifications in the autoscale group. So we've created a simple notification service topic, an SNS topic, and we've created a role associated with that, and we've tied it to the autoscale group automatically. So you can see there's an SNS topic. And this is a topic that the feature server will register for, so it gets notifications when it's being told to scale in, so that we can allow calls in progress to dry up gracefully. We've got an RDS database, so we can take a quick look at that. This is a serverless Aurora database. It's a very small database. There are not a lot of tables. required for the Jambones CPaaS, but there are some to hold some provisioning data, and that database is automatically generated for us. And we have an Elastic Cache instance, and we use that for caching information, variety of information. So we cache device registrations. We cache TTS, text-to-speech, so that we don't incur the cost of synthesizing text that we've already synthesized in a specific voice. Finally, let's go back to the EC2 instances. So our cluster isn't quite configured yet. We need to put some of our own specific choices in there. Now, to do that, if we go back and we take the IP address of the SBC server, and we go in our browser to that IP port 3001. It takes about a minute for the web server on the SBC to come up after the Terraform completes running. So if you go right to it and it doesn't come up, just give it a few seconds and try again. So when we go to the SBC public address, the Elastic IP port 2001, we have a web portal. The initial password, user and password, is admin. So log in as admin. You'll be forced to change the password on your first entry. Change it to something else. Now it's going to take you through a simple 3-step wizard to configure a few things. The first thing is an account. It creates a default account for you, and you can have actually multiple accounts. You can skip this if you want, but there are some choices you can specify here. Devices can register at the account level. So at your account level, you can specify a SIP domain that devices under that account would register for it. It's optional. You can not have this feature if you don't want it. And if you do, then you specify a webhook that will be called when devices attempt to register. There's more information about that on the docs page for Jambones. But we delegate the authentication of devices to your code. So let's say I'm just going to put a little webhook in there, and that would get called anytime a device attempted to register with sip.jambonz.us, which is the domain that I happen to give. So save that. Now we're on to step 2, create an application. So again, a default application is created for us. We can have multiple applications. Like any CPaaS, it's got a webhook. We can choose post or get, and we can use basic authentication, and we provide basically a webhook that will be invoked for this application. And again, similar to other CPaaS, there's a separate webhook for call status. So you can get a stream of call status events as calls come in, as they're connected, and so forth. So I'm going to go and just create a webhook with a path of initial app for my app, and then call status. Now down below, I get to choose, do I want to use Google or AWS for speech synthesis? And then I can choose the default language. So this is the default language for an application. I can override it at any time in the application, but if I don't, these are the choices that I'll get for speech to text. Again, both Google and AWS are available to me. I'm going to just stick with Google for now, in English. Speech recognition is Google only at this point, and you can pick any language that's supported by Google. So now I've created my application. Last thing is to configure a SIP trunk. Again, I can skip it and come back to it if I want. I'm using a trunking provider called 382com here in the US. So I'm going to put in their information. You can see that I put in their IP address as their gateway. So I need to put in the gateways that I'm going to be receiving, their SIP signaling gateways that I'll be receiving calls from. And if they have a gateway I'm supposed to send calls to, I put that in as well as an outbound address. Now you look up above, it says have your SIP trunking provider send calls to 54, 188, 125, 103. So that tells you the IP you need to have your trunking provider whitelist. So now I'm all set. Basically, I'm good to go. The CPaaS is configured. Got one other thing I would do. I've got some phone numbers from 382com, from my DID provider. So for instance, I would enter these phone numbers so that I can indicate which application to trigger when a call comes in on this number. So that's one of the numbers I've got here in the US. And I'll say I'll associate it with my default application. So now I've got a phone number. So now calls on that application will invoke, or on that phone number will invoke that application. And that's it. We've got some advanced settings, including Microsoft Teams, that we'll talk about in future videos. But this is it. This is all that's needed to set up a Jambones CPaaS in 10 minutes or less. Now, if you want to run that yourself, You can run it in the US West 2 region or the US East 1 region because I have the AMIs there. Or if you want to run it in a different region, ping me at daveh@drachtio.org and I'll gladly copy the AMIs over to the region that you want to run it in. The Terraform scripts require a couple of AMIs, one for the feature server and one for the SBC server. You can also build the AMIs yourself from scratch using the Packer templates that are in that very same GitHub repo that we checked out. Well, that's all for now. In future videos, I'll show you how to build applications with Jambones. I'll show you how to integrate with different trunking providers and some of the more advanced features like Microsoft Teams routing. Thanks and have a great day.